So this week's plan, first we're going to introduce tutorial 3. Covers super important concept at the first time, which is interrupts, and I'll show you one of the interrupt methods, which is called overflow interrupt. And there will be 2 tasks associated with it. So this is a heavy load alert. Okay, even though it's just the 2 tasks, but I deleted a big part of the code, original code, which I used for the demonstration to let you guys code it up ourselves. So I think I gave you several examples, including tutorial 1 and 2, to let you guys practice on C programming, and we did just C programming in class for the first 2 weeks. So I think I will see if you guys are ready to do it. Okay, just independently code up something according to a result you see in the video, one of the videos. So the ultimate one, which is this guy, the most difficult one, is to play a music game. So it play a, I think, let's see. I probably
to play the music game first.
How many notes?
To play the copy song, press R and press enter to send it. So listen to the pattern and.
So only 3 notes, right? Only 3 notes. Dun dun dun, and then you are trying to use a push button to duplicate that 3 notes with the similar durations of the notes. So you have to create a little error in your code to say, like, if the duration of the pushing is during this plus minus error, like several hundred milliseconds, then I play a success song, which means it's successful. Otherwise, play a failing song, which means it fails. So I just played it, right? So just 3 notes, dun dun dun. So then I'm gonna press the button for 3 times with a very similar duration.
Try to duplicate it by pressing the bottom button. That's a success song.
That's success song.
And then come back here, press R again. And now let's fill it. So that's a loose song. That's it.
So these 2 major application, major tasks. That's the final one. Okay, it's the most difficult one. But if we move up, keep moving up, that's 2.3. So task 2 has 3 subtasks. So task 2.3 is the most difficult one. And task 2.2 is a bit easier.
Play the test song. Press P.
So I just recorded the notes for the test song on the list. And I I actually typed something in the serial monitor, because serial monitor is UART. It has RX and TX, right? So when I'm typing something over here, I press enter. It's actually sending that byte or ASCII code, like byte, through the USB to the board. So you have to program something on the board to be ready to accept anything being sent to the microcontroller, right? So if I press, I type something over there, I press enter, it's gonna send it, and then it receive it, and then provide a certain response from the microcontroller. So it's actually sending things back through the USB, back to the serial monitor. That part is pretty simple. It's already given to you. Okay, don't worry about that part too much. So let's. So if it's actually asking you to. It's like a very simple user interface. It's giving you several options to let the microcontroller to run under certain modes. Okay. So if I press P, I put a P here. Right. P means just play. It's gonna play the test song.
Enter.
So it just plays it, right? That's the pretty simple one, because I already have the code, most of the code provided to you guys, and I think you just need to program the interrupt service routine a little bit over here. But the major part, including because we have to use the timer 1, timer 3, 2 ISRs. I'm gonna explain that to you later. Okay, so all the rest, the setups of the timers, the interrupts are already given. Okay, and all these user interface, okay, all the different modes is given here as well. Okay, that's task 2.2. And task 2.1 is already given, just like you guys. It's great booster. It's given to you. You just run it. If your board is working, it should be able to send something back to the monitor, and you should be able to see it. So it's trying to demonstrate the concept of static variables. So the static variables, if you put it into a function, if you close it for several times, so it retains the value. It's not resetting the value every time it's getting into the function. It's a new concept, but I'm going to show you later. If you don't understand that one, it's going to be very confusing. It will be very confusing later when you are dealing with the ISRs. So task 2.1 is 10 points is just given to you, okay? Easy. If you run it, you should get 10 points. Just show the results in the serial monitor. So for task 1 is already, it's given as well, as long as the board is working. I think the code, I don't have anything taken out from here. Okay, it's given. So task 1 is given. How many points? 20 points. Okay? So it's going to be 30 points given to you, pretty much. You just run it and show them in the reports. Okay? So these are all the tasks for this one. When is this due? October the 5th. It's a Sunday. So I'm trying to put all the deadlines for Sundays. What's that?
On Canvas, it says tutorial 2 is due on Friday, but on your website it says
Oh, I
Sunday.
haven't changed it back. I should change it. I'm gonna change it.
To Friday.
No, to Sunday. So which one is this guy, right? Homework 4, right?
Yes.
Yeah, it should be Sunday. I'm just trying to give you guys more time. Okay, it's gonna be Sunday. Okay.
On when is the midterm? Because it says review, break, exam, review.
Yeah. So I'm giving some examples during this class, right? Just talk about it. What will
Is
be
the exam on the 15th or the 17th?
15th.
And then we review on the 17th?
Yeah, I'm thinking probably we don't need this session. I'll just probably record a video. Probably recap, not review. I'm sorry. So review first, right? Preview and then review. Sorry, it's confusing. So I'm just trying to give you guys some feedback on Friday. That was the plan.
So definitely exam on Wednesday.
Definitely was, yes, exactly. After the mini break, you got a Tuesday to study it. Don't study anything during the break, okay? Enjoy the break. Because the midterm grade is due the 20th. It's the Monday after that week, So I have to get the midterm done before that. Any questions on anything? Okay, so I updated a lot of things during the weekend. You can see we pretty much already have the plan for the rest of the semester. Hopefully we can get everything done. You'll learn a lot from this experience. You can see tutorial 3 are the timers and everything. Then you guys work on that. Then Sunday next week it's due, and I introduced another tutorial here. Wait, no, actually. Okay, so while you guys are working on it, Monday next week, I'm gonna give you guys more instructions on that. Okay, for especially for task 2.3, the most difficult one. I'll probably give you some examples of the code to make sure that you guys can get things done. Because I'm pretty sure most of you guys are still working on tutorial 2 this week, right? Okay. So, but some of them already, 1 or 2 people already get it done already. So, but the rest of you guys will work on it Tuesday, Wednesday, and hopefully you guys can start working on tutorial 3, right? Later this week, and at least for tasks 2.1, 2.2, okay, or the simple ones, right? The ones already given, solutions already given to you, okay. And next week I'm giving you the time to work on it. See, I'm not covering new things on Wednesdays and Fridays. I'll just cover more examples on Monday. I'll give you the time to work on it, okay, since I know it's difficult. And then the week after we do tutorial 4, okay, on PWM, another super important concept. I'll play with the RGB LED, and at the same time we do our midterm. but this is due to 2 weeks. Okay, I'm giving you 2 weeks on it, but at the same time, you are also study your midterm, okay, at the same time. And then we do another one on the IR module on the board. The IR module, IR transmission is, I'm merging a couple of other different examples into one tutorial, so make sure we can get it done during 2 weeks. So during that 2 weeks, we need to work on the PCB design because it takes about 10 days to be fabricated by the factory and then sent back from China to here. So in that case, I'm gonna let you guys work on some of the tutorials, right? So I will make that simple because I know it's can become massive very quickly. So we'll probably just get the core of the PCB, for example, design, place that microcontroller on it, get a USB port, just maybe 1 or 2 sensors, right? Don't make it too complicated. And then we get a PCB done the 7th of November. I need to receive the files by that day so I can send it to JLC PCB for fabrication. Right? That takes 10 days. It's already like early this first week of November. We send it out. We're probably expecting during the Thanksgiving probably, and then you have about, let's see. Okay, when we're back from the Thanksgiving break, I'll let you guys start soldering and do the testing. Okay, and then Friday of that week we do a final exam review. It's like a week. So is that a Thursday? 11th of December? It's a Thursday. It's pretty late. It's probably the last one. Yeah, I'm sorry for that. Would you like to take it earlier?
Yeah.
No. Earlier in the morning?
So the thing is, because I want you guys gain the most from this class. So if you guys started assembling the board at the beginning of the December, it probably takes a week, I think. Hopefully you guys already have the experience of assembling that. And I don't want to make the final report due too soon, right? So since we have the final exam on Thursday, so I'm putting that final project report due Wednesday. Hopefully that's reasonable. So I have a lot of time, about 2 weeks, maybe 10 days to work on that soldering and testing. Okay? So the 17th will be another tutorial, and the third is SD card. I want to make maybe this one just have a really quick DDS so you guys can understand and study the concept and get something done. But I will make this really short, just 1 week task. Okay. Don't want you guys to work on anything during the break. So we should get everything done by Sunday, okay, or by Friday hopefully. For this one, this short one. And we do need 2 weeks on SD card and SPI. That's a very important technique to know, and will be very beneficial to your senior seminar project in the future. A lot of times you need to log data to SD card, like the GPS and like our senior sem project. You need to understand SPI, right? What is SPI? What are the interface connections? Double buffering. So while you are sampling, so this involves a lot of things like ADC as well. When you are sampling, you are also transmitting data to the SD card. It's super important technique. Right? A lot of things to be put on the resume. After this class, you have like another half pages to be added to the resume as a course project, hopefully. At least you know PCBs, you can put all these techniques like double buffering, SPI, SD card, all these kind of things. Okay? Any questions on anything? All right, let's talk about the in-class exercise. You have a copy. Okay, so the speaker. If you don't see this page, refresh the browser since I just added this morning. Refresh it or delete the cache in the browser. Refresh it. So if you click this link, you can find the vendor's manufacturer's website of the speaker. Here's the speaker ordered, and here's the diagram. right? And so the one on my website is better. So you can see this one, x-axis is a frequency, and the y-axis is the gain or the sound volume probably. And you can see the unit is dB. So that's the unit of the volume. And so the question for this is, using the frequency response graph, which is this graph, in the technical documents, what frequency does a speaker produce the loudest sound, and what is the magnitude of this sound? Loudest. Here, right? You just need to estimate. It doesn't have to be accurate. So this tells you that it's not always playing the same volume under different frequencies, right? So this is the loudest here, and if the frequency is too low, you are expecting a lower volume from the speaker. And the second question here is, one more thing. So this, between these, so this is still a deck, no, that's 2 times. That's interesting exercise, axis. It's not really a decade per division. It's just trying to put all the data points in one graph. But that's all right. So definitely you need to know that this is 5K, then this is 6K, right? So the point here is going to be below 5.5K. So just pick up number between 5K to between 5K and 5.5K, I think. Just an estimate. Doesn't have to be accurate. And question number 2, a person with good hearing should be able to detect sounds with a volume level of 70 dB. What is the lowest frequency for the speaker that has this volume level?
400.
So you are looking at the y-axis first, right? So 70 dB is over here. And all these ones are above 70 dB, so it's fine. But it's asking for the lowest frequency which can reach that volume, right? So you guys can tell from the graph. I mean, all the frequencies above this line is fine, right? But only this range will below 70 dB. So if you want to play a volume larger than 70 dB, the frequency of the sound need to be higher than something, right? So that's the number you want to pick up from the graph. So basically, anything lower than that won't be able to heard by a person, for most of us. Number 3, the technical documents for the audio amplifier LM4862. By looking up its part number from the well, we don't have the bill of materials, but I already put it here, the data sheet. You click it, and here's the circuit diagram for that audio amplifier. So that's the footprint or pin out. Do you know where's the audio amplifier is at on the board? I can definitely look at the number of pins, 8 pins, right? And it should be relatively close to the speaker's connectors, right? So which pin is used as the input?
4.
Number 4. So this guy. Number 4 is this guy, right? Here.
Isn't it after the cap and the resistor?
Yeah, I mean, so that here's the chip, right? Here's the chips and pin. But I think our circuit has the cap and resistor already added to it. It's a high pass filter is blocking any DC offset before that. So only oscillations can pass, right? All right. Number 4, what is the overflow interrupt vector for timer 1? Show the name on the data sheet. So I want you guys to show the name of the vector from the data sheet, and then the keyword that should be used for the code. So let's look at the first one first. Okay. So what's the name of the vector? So vector means whenever it triggers an interrupt. So what is the interrupt first, right? Interrupt is a new concept. So whenever you are running the code, if you look at the code, it has a permanent loop, right? Including this Arduino microcontroller, but also other ones as well. In other microcontrollers, it's called main. It's a main parenthesis. It's a main function. But this one uses a loop function instead. Okay? So the loop function, if you don't have any other or interrupts to interrupt it, whenever it finishes the setup function, it's going to get into the loop function and keeps running back and forth inside. It's going to cycle back and forth in the loop function. It's a permanent function, a permanent loop. Okay, so in order to make our microcontrollers more capable of handling multitasks, so we want to add interrupt service routine or ISR to it, so which is able to interrupt, based on the signals, right? So, for example, for this tutorial, we are using an overflow interrupt. So timer counter 1 overflow interrupt, which means whenever it overflows, it finishes all the counts, it interrupts. So slightly different from the one we did in tutorial 2, because in tutorial 2 we don't really actually call a function after it overflows. We're just looking at the flag, right? If the flag is on, we do something, but we don't really jump into a function. So if you jump into the function, they'll allow you to do a lot of other things, because you can put a lot of operations inside that function. So whenever overflow got triggered, it gets into ISR and do a lot of things for you. Okay, so that's a goal here. So what's vector's name being used for the ISR? And the answer is just over there, right? Okay, so but if you look at the data sheet, it's different. Okay, so these are all the vectors or the sources of the interrupts. So whenever you use timer counter 1 overflow interrupt, it's one of the modes. There are so many different modes of interrupts. So the mode we are going to use for this tutorial 3, is called the timer counter 1 overflow interrupts. Like I already explained to you guys, whenever it overflows, it interrupts. So the name of the vector over here on the data sheet is called timer 1 space OVF, it's overflow. Okay. But this is not the keyword you want to use for the code. It's only able to detect this. This guy. So that's a keyword. Okay. It's case sensitive. You have to add an underscore there. So it's timer 1 uppercase underscore OVF underscore vect lowercase. As a keyword, cannot change it. Okay, so when that one is getting detected, all right, it enters ISR. Enters ISR. Okay, so there will be all different types of vectors for different modes of interrupts. So this is just for overflow for timer 1. Overflow and timer 1 vector. Okay, and then come back to schematic. So what about after interrupts? So the loop function is running back and forth, right? Can you really tell when it's going to interrupt the loop? It's depending on the timer, right? But the thing is, you really don't know where it starts interrupting the loop function. It's just keep going like this, right? And then whenever the timer is running behind the scene, the timer is running to us, and interrupts, right? So it could happen in the middle, right? For example, in the middle of the loop function, and interrupts and go to the ISR and run whatever in there, and then it will come back to the same location. and keep running the rest of the code. Okay, that's how that works. Okay, number 5. So to answer the question number 5, we have to look at the schematic. So here's the schematic. We are engaging that low-pass filter in here. It's able to get rid of some of the noises. It's not required actually, but we decided to do it. So there are 2 jumpers you need to install on the board. So one of the jumper is actually not really just 2 jumper header pins on the board, individual ones on the board. It's being put in the same row as a long row of header pins. Can be a little bit confusing. It's here. Okay. It's right at the edge. So the last 2 pins here is this guy. I forgot. This guy or this guy, I forgot. We can take a look at it later. But so you need to install jumper header, the jumpers, the little jumpers, which is shorting these 2 pins. You can find them in the drawer in the lab. So here and here. So it's actually JP5 and JP6. Okay, so JP5 and JP6, these 2 header pins. Okay, I think this guy is JP5. Yeah, this is JP6. All right. So to run the setup function, you need to enable the interrupt. So that could be very useful. A lot of times you want to disable the interrupt for a certain purpose. You can put in the if statement, and if this happens, I want to disable it. But by looking at this one, you can see in the setup function, we don't really have a lot of settings or configurations to the interrupts. You can see at the very beginning, we clear interrupts. So there are many ways you can do a no interrupt parentheses. Can do the same thing, but we are using CLI. It's a function, embedded function that I can directly use. It's clearing interrupts parentheses, right? Clear the interrupt, and then we do the normal operations of the 2 registers just to run the timers under the normal mode. We have been doing this for 2 tutorials, several tasks, and then we set up timer 1 as 1 to 1 per scalar. So it's not actually slowing down the major clock, the frequency of the clock. And then we enable the timer. And we want it to be a timer 1 overflow interrupt. So the way to do that is setting the LSB of the timer interrupt mask register to be 1. So here's a register. I have a snapshot on my website. That's a certain register that I can enable your timer 1 interrupt, overflow interrupt, which is over here. So the name of the register is called timer counter 1 interrupt and mask register, and you can see the one we are interested in because you can run it at different modes. Okay, you can see all these registers are controlling that under different modes, but the one we are going to use is the overflow one. So we are actually setting timer TOIE 1, right? So TOIE means timer counter 1 overflow interrupt enable. So O is overflow, I is interrupt, E is enable. So you put a 1 there, it enables interrupt. Once this one is being set, if you have a timer starts counting, right? Whenever it overflows, it's going to trigger ISR. It's going to run the code under ISR. So that's how you control it. So it's great. Seems like everything's under control. I can control the timer. I can control the interrupt. I can turn it on and turn it off. Enable, disable. So number 7, number 8 is just a Arduino code, just one liner, right? So we have been doing this for 2 weeks. Remember, how do we set a bit in the Arduino code? Arduino C specifically? What's the code? What's the one-liner code? You'll do it. Similarly for number 8. So what's the one-liner you set up? You set that LSB, right, to enable interrupts. It's a pretty simple question, so we can definitely get this turned in today. Okay, great, first time. Any question on anything? What's that?
Oh, where is the timer mask 1 register?
That's over here.
It says where is it?
Oh, where is it?
It says where is it, not where that is.
Oh.
It's saying where is that in.
Oh, okay.
Oh, where's the in? Okay. Yeah, really confusing. Number 6, right?
Yeah.
Yeah.
Yeah, that's right.
Cool. It's asking where is TUIE1 is in that mask register. Any other questions? Cool. Coming to class today, getting 13 points for free, almost. Any questions? No? Okay, let's keep going. By looking at the code here, the first example. So the first example is doing what? It's doing this. Okay, so I have three different modes. Okay, 3 different modes. Let's show the video first.
Okay, so first I can use a lowercase n, type of lowercase n over here, and then press enter to start playing, and use lowercase I, enter, lowercase I, enter, lowercase I, enter. Keep going to increase the index, and use the uppercase N, shift N, and press enter to stop it. I can use.
That's it. So it's basically just you start, you turn it on, you press the button to start N. So lowercase n is to start playing one note, right? After it's been sent, you don't touch anything. It keeps playing. Keeps playing. So which means the interrupt function keeps going. I will explain to you why the interrupt is controlling the frequency. Okay, we'll look into that really quick. So then you press I. So I is the index increase command. You press I and you press enter. It's actually sending that I command to the microcontroller. Microcontroller receives it and starts increasing the index of the note on the list. So it's cycling through all the notes on the list. And you put an uppercase N to stop everything, right? So because the sound is pretty annoying. It's not a beautiful sound. So you can stop it. So it's good to have that function in there as well. And that's it. So that's for the first one. The code is given. So it's very important to understand what's going on with the code. Now let's get into it. So keep in mind, you send a command, it keeps playing. Okay, it keeps playing until it receives another one. Right? Keep that in mind. So it's basically waiting for the ASCII code or a byte to be received, because every time you type a new letter in it in the serial monitor, you send it. It detects it, right? Detects and receive it, and try to determine like what has been received. So in that case, you need a mechanism here to wait, right? To wait. Or if nothing is getting received, you should skip this whole thing. So here's a function to be used. Serial.available. Serial.available. What does that mean? When this guy is true, so when this guy is true, right? Which means something's getting received. Something's available. So in the serial port, There's actually a little buffer on the motherboard of the computer, okay, of that UART module. Whenever there's something being received, it's being saved in a sort of like a buffer register first, and it's gonna trigger a flag, but we are not dealing with it because everything is being embedded into the serial available function. We're not worrying about that. So whenever everything is getting received, it knows it, okay? And this one becomes true. All right, then we read it because something is already received and being stored in the buffer. It's temporarily being stored there, and we read it and we send it to this CMD variable. So it's being stored is a CMD variable. So you can imagine if you give an n, right, give an n, lowercase n there, and it's gonna detect it and it will enter this if statement, and then you immediately do a reading, and it will save that I. ASCII code of I, right? Whatever that is. Oh, sorry, N into CMD. Right? Because we typed N here, N is being received. So for this switch case statement, it enters the second entry here, which is case N, right? And then the serial monitor will print something first because the user selected N. And the serial monitor reports start playing note, right? Just let the user know it starts playing note. Okay, and then set up a flag. We use these flags a lot in the future. Okay, so the flags. Play note is a variable, but it's true, right? It's a boolean. It's a bool variable, I believe. Let's see. Okay, it's a bool variable. And this one we set play note to be true. So because we want to stay playing notes, right? So play note flag to be true and break. So when it breaks, it's not going to do anything else, right? It just directly breaks the switch case statement. If you didn't take C++ in the past, take a look at it. So switch case is looking at this one, this variable, and it's trying to determine which entry to go into, depending on the value being stored in this variable. Right? If we put an n here, so it's going to enter case n, right? And then run this type, part of code. And it's going to break. It's going to break. So when it breaks, it's not going to execute any of the following code. It will directly break at this point and exit the switch case statement. Will directly reach here. Any question on this? No? Alright. So press N is stored, it set this play note flag to be true and then exit. Why is that useful? Because if you look at the setup function, I already turned it on. So the timer is on, right? The timer is on. It's a 1-to-1 prescaler. And the timer 1 interrupt is on as well. So immediately, whenever it finishes the setup function, the ISR will start, the timer will start counting, and the ISR will start running. Okay? But the thing is, if you don't press anything, if you don't press N, right? If you don't start playing it, play note, this variable will be false, right? So in that case, whenever it enters the ISR, so ignore this one for now, okay? I'm going to tell you why. So this is false, and this is false, right? So it won't run this as well. It won't run anything. It's just running a time delay function, but the time delay function is not doing anything. Oh no, it's not even running this. No, it's not, because it's finished. The ISR finishes at this point, this location. So these are not being called, I think. Let me see. Are they being called somewhere? Oh, being called here, being used once here. It's just, creating a 500 millisecond delay trying to set up the serial monitor, a serial communication, right? Whenever it's being initialized, right, we give a little delay so it's not rushing, and then it's ready to do all the printing. I mean, sometimes if you don't have a time delay after the setup, it's still going to work, but just be safe, right? So adding this delay function over here. All right, if you don't push anything, what is the play note? False, right? Okay, and these are also false because we didn't press I either. So these are all false. So it's not running anything. Even though the ISR is running, it's actually interrupting the loop function, you know. But the loop function is not receiving anything as well. It's basically not doing anything, right? It's just getting to the loop function. It's not detected. It's not getting into it. And it's just printing out this little symbol here. And then this loop function is being interrupted, you know. But it's not doing anything. Okay. So if you press N, play note becomes true. And interrupts still working, right? Still doing whatever it's been doing. And whenever it interrupts, this is being detected. Okay? And then immediately you set up your timer counter 1 value in there, in this TCNT1 register. So setting up a offset, starting value to it, right? That's the value determined by the note, the counts of the note. Okay? And then toggle the pin. So my question for you guys is, so once this is set up, what's gonna happen actually? I mean, it's right now it's in the interrupt in the ISR function, right? It's in here. It's right in it. And that ISR is triggered by timer 1's interrupt. And now I'm changing the value in the timer 1. I'm actually resetting it to a new number. Okay? Is it going to wait until this is done, or it's going to run the toggling of the speaker pin immediately? Am I losing anybody? I'm losing everybody? Is anyone comfortable with the interrupt concept? Like interrupting in the middle of the loop function? Okay? So this guy is think about it. What's happening? What's really happening here? So interrupts and enters here, right? Because the play note is true. Is that true, right? And whenever it enters, I give a new number to the timer count. Okay? So the timer will be set. The timer counting register will be set with the new counts, right? Behind the scene. So then the new timer will start working, start running. So my question is a timer, is it actually waiting here until the timer is done, or it's gonna run this code, this line immediately? Immediately, okay. So there's no while loop. Why does it wait, right? There's no mechanism to wait. So this guy, but it's still within that interrupt function. So this is just a number being set up to the timer counts. So it's running at the behind the scene, right? It's running behind the scene, running there. I'm gonna set up the timer here, start counting. However, I'm gonna flip the pin, and then exit. It's done. ISR is done, right? The timer is still running behind the scene. I got a new number there set up. Until when? Until another loop. Until it finishes the counts being set up over here, right? And it finishes over here. It's running behind the scene. Keep in mind, ISR is running here, right? So timer is running here. Okay, so next time, whenever the new number in the timer is, so the timer is up, so enter ISR again, right? Enter ISR again because the timer is already up. I want to set up the, plot that that counts into the timer again, right? Which is this line is doing what this line is doing, right? Do it and then flip it one more time. Okay? And just keep doing that so you can. So the ISR and the timer is controlling which time period? Very simple question. Which time period? Where's the ISR is controlling? Half period, right? Because every time when the timer's up, it toggles it once, right? So it's actually when timer's up, toggle it, timer's up, toggle it. Timer's up, toggle it. Make sense? So we're using ISR to toggle that pin. Oh, that's an overkill. Just toggle it, right? Just toggle a pin. Why? So you learn how to use ISR to toggle a pin. In the future, we have. So this is just super fundamental example, right? But in the future, we have the music game. Then you have to use two interrupts to control that thing. One is for duration, one is for the note itself. It's getting more complicated, so you can find out like why we have to use interrupts. There's no way that I can control different tasks with just one simple loop, right? I have to interrupt it to do something else and come back. That's how that works. All right. Any question on this? No? What about increment? So increase the note. So when I'm remember the video, right? Remember the video? If I press lowercase n, it starts playing, right? It starts playing that single note. Then I press I to increase the note. But it's not stopping playing, right? It keeps playing until I press I, it plays the next note, but there's no interrupt in the middle. It keeps playing. So that is why whenever you press I here, you turn on this flag, which is increase note flag, make it true. And whenever it enters ISR, it just has one more entry to run. That's it. So this is still true. This is always true. This is always true, right? Because we already set it true, right, by pressing the lowercase n. And whenever this is being set true, the only difference is the index of the node is getting increased by 1, right? And I'm checking if I'm already going beyond the limit of the scale, right? If it is, I'm gonna set this index to 0, so it's coming back to the first one. And I wanna, immediately set increase node to be false right after it. Why?
So that it doesn't just.
It doesn't keep increasing, right? So it has some time to play that note. Otherwise, you couldn't hear anything. It just keeps changing, right? Keeps changing. Oh, yeah, that's right. So you immediately set it to false, so it's not keep increasing. It just increase once. But every time you press I once, it increase the node index by once. By 1, okay. So that's everything here. Just 2 entries, pretty simple. And why we are using this? Why we are having like a test pin high, test pin low. Why is this useful?
So we can see when it jumps into ISR
Yeah,
on oscilloscope.
yeah. Since you set up everything in the setup function, so in the future when the code becomes longer, right? You're unsure where the problem is. But the thing you definitely know is it's not working. They start debugging it, right? So what is the problem? Is it really getting to the ISR? I don't know, but how do you test it? So you put a pin here, right? The test pin is a physical pin on the microcontroller. I picked up pin 13. You can pick up anything, right? Any digital pins on the board. And I plug in a function to write a high to it whenever it enters it, and I write a low to it whenever it exits. So basically, if it enters ISR, if it enters it, I'm gonna have a pulse, right? It turns it on and it runs all the code here, which takes time, right? And then eventually pulls it low. It's creating a pulse. If you connected pin 13 to an oscilloscope, you will see a pulse, which means it enters ISR. So you know that part works at least. So the problem is somewhere else. So you can start debugging something else instead of the ISR. Okay? What's another benefit of doing this? Anything else you want to look into by doing this? Can you imagine? Anything else? So we know it gets into ISR. What else you can get from this? What else you can measure? Think about it.
The period before it.
The period, yeah. So if you measure, use a cursor, right? Bring up two cursors, so that pulse could be really narrow, could be really wide. So that's gonna be really important information as well. So you'll know how long the ISR takes to finish. Okay? ISR shouldn't be very long. Keep in mind, interrupts should be short because it's called interrupt. That's not the main job, right? So the main job is over there. You interrupt, do something, come back and do something else. If you interrupt it for like 10 years and then come back, so you want to change the name to main, not interrupt. Make sense? You want to keep it short. So for this application, what is interrupt doing here? It's creating an oscillation, right? It's really short. So that's why we can use interrupt for this application, because it's an oscillation of the sound. It's really short. That's a really good example for interrupt. Any other questions? Anything? All right, let's come back to the tutorial. What's happening here? I'm losing a figure or a video. YouTube video, demonstration video here. So I remember you guys had some problems with the printing. You're printing twice, and I just Googled it. It said you have to change this one to no line ending instead of new line, and that will probably solve the problem. Hopefully it solved my problem. And here, static function. I can spend 2 minutes to get this done easily. So by looking at this function, okay, this is executable. You can directly copy and paste to Arduino and connect to the USB to the computer. You should be able to see something from the serial monitor. And here's the setup function. Definitely just set up the UART, right? And then the loop function start running, and the loop function doesn't do anything but it's calling this function, this sub function. So my function, right? So my function, sub function is over here. It's not returning anything. It's a void, not returning anything. And so keep calling it. That's a dead loop. Only delay for one second. Delay for 1 second and keep calling it. Okay. We'll part it up, run, right? Call it. Okay. And then delay. And come back and call it. Right? So when it calls this function, you can see this is calling this function for many times, right? So keep calling it. Okay? But setting up the static variable, you can see every time it calls it, hey, this is being set to 0. Okay? It's gonna be a problem. By setting this to a static variable, it retains the value. It's not really changing it. You know what I mean? So every time it calls it, even though this is like giving a 0 to it, it only give a 0 to it at the very beginning for the first time. The second time, you're getting a 1 here. It's adding a 1. So it's not really setting 0 to it. You know? So that's something you need to know if you haven't taken C++. And we are going to cover task 2.2 and 2.3 I think next week. I think you guys have a lot of tasks to work on this week, right? We don't have to rush to 2.2 or 2.3. If you can finish all these ones, that'll be great, including tutorial 2, right? Okay, cool, that's it.